Welcome to radar system course. So today we see few numericals on AMTI radar. So we have seen the topic of AMTI radar, moving target indication, as well as the tracking radar. In the moving target indications, we have seen that there is a Doppler shift. We need to identify what is the target, and then in a tracking radar, we need to find out a target and its location in terms of a angle or in terms of a range there. Okay, angle is nothing but what? Elevation angle and a azimuth angle, and a range that is in terms of a kilometers or a miles there. So we see here a numerical on this particular topic right now. So an MTI radar, so we continue here, and a MTI radar operates at a PRF, that is a pulse repetition frequency of 1.5 kilohertz. Full stop. It's operating its operating wavelength is 3 centimeter. Determine determine lowest blind speed. Determine lowest blind speed. Okay, so now we need to find out what is the lowest blind speed for the given values of a PRF 1.5 kilohertz, and that wavelength is given, it is about a 3 centimeter. So while solving, we need to know about what are the data given and what will be the a blind speed. So PRF is given, that is a pulse repetition frequency is given, it is about 1.5 kilohertz, and this wavelength is given is about a 3 centimeter, and our aim is about to find out what will be the a blind speed. To find out blind speed, we need to consider that what is the equation of a blind speed. So generally we say that a blind speed is equal to, generally we say it is about a VB, and if you want to find out this VB, okay, that is about the VB is nothing but the in terms of the velocity is equal to, that is n is nothing but what? A number, that is about, n is a number, integer number, n stands for 1 2 3 4, likewise n number, and here we say that it is about the lowest blind speed. So for a lowest blind speed, that n will be becomes a 1 here. If we require a 2 speed, say n 2 3, likewise. Okay, so we require value of a n here. So how many speeds we require? So according to that, n will change lambda by 2 into a PRF. What will be the pulse repetition frequency? So if you put that n is equal to 1, why n is equal to 1? Because n equal to 1 will give you the lowest speed, okay, lowest blind speed. This one is about it, n. So n is equal to 1, that will give us the lowest blind speed. So that's why if you solve it by putting the value of n is equal to 1, so then we will get that VB is equal to 1 into, we have a wavelength is given 3 centimeter, so we can write in terms of a 0.03, it is in terms of a meter here, by 2, because velocity in terms of a meter per second, and we need to know about what is the pulse repetition frequency. That pulse repetition frequency is what? 1.5 kilohertz. Okay, so this one is nothing but what we are expecting the values of a blind speed. So once we solve these blind speed values, we will get that a VB is equal to 22.5 meter per second. Okay, that is about a blind speed. So, if you see here in this equation, we have considered that a value of n. Suppose if it is asking, we need to operate or we need to find out the n number of a blind speed in that case. So we need to know about that what will be the n. So there will be the lowest blind speed. If supposed to be if that question is different in terms of that we need to find out the three lowest blind speed frequency. Okay, velocity. Okay, or we can say that four blind speed, five blind speed. So according to that, n will change. So n will be 1, 2, 3, 4, 5. Okay, and that lambda and PRF is given. PRF, that's about a pulse repetition frequency. If it is given that instead of a pulse repetition frequency, if it is a pulse repetition time, okay, this value will be a pulse repetition time is given. So we need to convert that time into a frequency there. So you should remember that what is the equation for the a blind speed there. Blind speed is equal to what? AVB is equal to n into lambda by 2 into a pulse repetition frequency. We proceed to the solving another example here. We consider that a next example. Next one, a MTI radar. Again, we have the issues with what will be the blind speed. So blind speed consists of what? It is about a PRF. It is changed if PRF changes, blind speed changes. Okay. So now next, an MTI radar receiver an MTI radar receiver indicated a Doppler shift indicated Doppler shift from an automobile as 1.0 kilohertz. The radar is operating. The radar is operating at a frequency of the radar is operating at a frequency of 10 gigahertz with 10 gigahertz with a PRF of 1.0 kilohertz. Find the speed of the automobile. Okay, right now we consider that this automobile is nothing but even target. Okay, so in that case, so what will be the speed here? So what will be the speed of your automobile? We need to find out here. So that speed of your automobile, if you consider that while solving, we should know that equation of the speed of automobile. So that speed of automobile that will be depending upon that what will be the Doppler shift here. Okay, so we can write here the equation speed of automobile is equal to what? A Doppler shift with respect to the environment. There is no role of what? That PRA, okay, pulse repetition frequency. Pulse repetition frequency when it requires at the other rate. Okay, so right now we need to know about so what will be the Doppler shift and what will be the wavelength here. Okay, so So radar operating frequency is given is about 10 gigahertz. From this 10 gigahertz, we need to find out the what will be the wavelength. So f is given is about 10 gigahertz. From this f, we need to find out the lambda. Lambda is equal to what? A c by f. Okay. C is nothing but what? 3 into the raised power 8 divided by f. That will be about what? 3 into the raised power 9. So if you solve it here, so we'll get that here lambda that will be of a 0.03. Lambda will be a 0.03. FD is given. Okay, so already we see that the Doppler shift from an automobile as a 1.0 kilo. So if you put the values here, FD Doppler shift frequency that is given 1 kilohertz, 1.0 kilohertz, 1 into 10 to the power 3 into your lambda that will be a 0.03 divided by 8 to 0. So after solving this one, okay, when we solve this above expression, okay, after this one solving, so what we will get? We will get the value of speed VA here. So VA we are getting, that is the speed of automobile we are getting is about a 15 meter per second. Now we need to convert that a meter per second in terms of what? A kilometer per hour. So convert that to 15 into a kilometer per hour. So we can write in terms of hour that is about 3600 and kilometer in terms of a thousand. So we will get the answer VA is equal to 54 kilometer per hour. Okay, so we will get directly the value of a VA that will be of a 54 kilometer per hour here. Okay, so here is we can solve it in terms of a meter per second also. Okay, so but generally we know that the speed we are measuring in terms of a kilometer per hour. So that's why we need to convert that in terms of a kilometer per hour. Okay, so we will get the value of a speed of automobile, or we can say that a speed of a target that will be of a 54 kilometer per hour here. Okay, so we can proceed to further one. Okay, so here if we consider that radar receiver indicated what will be the a Doppler shift here. Doppler shift from the target. So from the target, okay, so means receiver send the pulse, then it consider that there is a shift of a frequency. Okay, so that's why you can say that it is about a Doppler shift of 1.0 kilohertz. And based on that Doppler shift, we can find out the what will be the speed of that target. Next, what are what are the three lowest blind frequencies of the radar when it is operating at 10 gigahertz with a PRF of 1.0 gigahertz. Okay, so that is about what are the three lowest blind frequencies of the radar. Okay, so we need to find out the blind frequencies. The blind frequencies, if you solve it, the blind frequencies are equal to what? blind frequency equal to, with respect to what will be the APRF here. So that blind frequencies we can write here, that will be a Fn. So Fn is equal to what? What will be the number of frequencies we need to obtain, that is about n into, we can consider that a PRF. Okay, so what will be the PRF now? N we can consider that how many number of frequencies we require. So it is saying that what are the three lowest frequencies. Okay, question is that what are the three lowest flight frequencies of the radar when it is operating at a 10 gigahertz. Okay, that is about your lambda. Okay, wavelength. And a PRF is about a 1 kilohertz. So at a given particular PRF value, the PRF is about a 1 kilohertz is given for the given particular PRF value. So what will be the a blind frequency? So if we consider that n is equal to what, 1, 2 and 3, because we need to find out the three lowest blind frequencies. So for the three lowest blind frequency, we can write n is equal to 1, that is first frequency, n is equal to 2, second frequency, n is equal to 3, third frequency. So we can find out f1 is equal to 1 into what, PRF? PRF is equal to 1.0 kilohertz. We can write here into 10 to the power 3. So we'll get here 1 kilohertz. Okay. So similarly, we can find out f2 is equal to 2 into 1.0 10 to the power 3 is equal to what? 2 kilohertz. Then f3 is equal to 3 into 1.0 into 10 to the power 3 is equal to 3 kilohertz. Now these are the blind frequencies. These are the three lowest blind frequencies. So you can write here the lowest blind frequencies are 1 kilohertz, 2 kilohertz, 3 kilohertz. These are the, we can say that, a lowest blind frequency. Okay. So now we need to find out here. So for the given particular, okay, blind frequency, what will be the blind speed also? Okay, so just like number of frequencies. Okay, so what we can consider blind frequency, instead of that even we can find out that what will be the number of a blind speed there instead of a number of blind frequencies there. So we will solve a similar one here. If an MTI radar, if an MTI radar operates, if an MTI radar operates at 10 gigahertz with PRF, okay, with a PRF pulse repetition frequency of 0.8 kilohertz, 0.8 kilohertz. Find the three lowest blind speed. Okay. Now, as we know that a blind speeds, okay, so just like we have considered that earlier case, we have found that what do you mean by the a blind speed there. So that blind speed is equal to what? A VB is equal to n lambda by 2 into PRF. That is about a pulse repetition frequency. Okay. So now we should know that what will be the n value, because we need to find out that a three lowest blind frequency. So in that case, we need to know about the value of n. N is 1 for the first blind frequency, n is equal to 2 for the second blind frequency, n is equal to 3 for the third blind frequency. So we can find out here a first blind speed. In that case, VB1 is equal to n is equal to 1 is equal to lambda. Lambda is equal to what? It is given operates at a 10 gigahertz. So if you solve for the lambda wavelength, lambda is equal to c by f. So it will be what? 3 into 10 to the power 8 by whatever the frequency, that is about 10 gigahertz. So it will give us a 0.03 here. So 0.03 is nothing but a lambda divided by 2 into a pulse repetition frequency. What is the pulse repetition frequency? Pulse repetition frequency is a 0.8 kilohertz. So 0.8 into 10 to the power 3. So if you solve it, okay, so we will get that 2 into 8, that's 8 divided by 2, that's 4, 4 into 3, 12. So okay, so we can get the value number is about a 12 meter per second. So we are getting that the first blind speed, that is about a 12. So similarly we can find out for the second. So VB2 is equal to what? 2 into 0.03 divided by 2 into 0.8 into 10 to the power 3. Okay, so 12 into 2, that's about it, 24 meter per second. So similarly we can find out a third blind speed for the third. So VB3 is equal to 3 into 0.03 divided by 2 into 0.8 into 10 to the power 3. Okay, so we will get that a third blind speed, that will be equal to what? A 48. Okay, so we need to find out, so what will be the blind speed now? Okay, so this one is about a 12, 24. Okay, so this one is about 12. This one is not 20, 48. This one is about a 36. Okay, so likewise, so 36 meter per second. Okay, so now we can find out here, instead of a frequency, we obtain here that a blind speed, that is about how many number of a blind speed, n number of a blind speed we can find out that through the a pulse repetition frequency. Okay, so we proceed to the next one, solving another numerical, and then we'll see that we'll conclude regarding that blind speed as well as the tracking radar. So next one we can find out, determine PRF, pulse repetition frequency PRF of an MTI radar operate. Okay, that's about the operating frequency of a radar operating at f is equal to 10 gigahertz if it has if it has the lowest blind speed of a 20 per second. Okay, so we can consider that. What about the terms given? So means that or a track or a target, we can say that it has a lowest blind speed of what? A 20 meter per second. Okay, so at what particular frequency at a f is equal to 10 gigahertz. So already we know that a blind speed, okay, so that equation of a blind speed that we can consider if we solve it, that is about a blind speed equation. So what will be the blind speed equation? Blind speed is equal to VB is equal to what? What will be the n? N into lambda by 2 into PRF. Okay, blind speed is equal to this one, Vb is equal to what? N into lambda by 2 into PRF. Now that lambda is the wavelength. Okay, so lambda is equal to what? C by F. 3 to 10 power 8 divided by 10 gigahertz. Okay, so we will get that is 0.03. Okay, that's about your lambda here. Now, PRF. Our aim is about to obtain the PRF, determined PRF, pulse repetition frequency. What will be the pulse repetition frequency? So we can put here the value of a VB. VB is equal to what? N lambda by 2 lambda is equal to what? It's 0.03. That is the meter. That is about the lambda value. And N, because a speed, okay, it has a lowest blind speed. So N will be what? A 1 for the lowest blind speed. So then what will be the PRF? PRF is equal to what? That is PRF is equal to what? Twice of what? A blind speed VB divided by a N lambda. Okay, that N will be what? N will be 1. VB is equal to what? A blind speed. That is about 20 meter per second. So we can solve it that 2 into what? 20 meter per second divided by N is equal to 1 and lambda is equal to what? A 0.03. Okay, so after solving, we are getting a PRF, that is about a pulse repetition frequency is about a 1.33 kilohertz. Okay, you can put the values, we will get that a pulse repetition frequency equation here. Okay, so from this blind speed, we can find out what is the PRF required. So generally, we consider that a highest PRF for what to get the range proper here. Okay. Now next, we need to solve another one. What is the maximum? What is the maximum unambiguous? Okay, we can find out what is the maximum unambiguous range if a radar if a radar operates at a PRF of 1.0 kilohertz. Its operating wavelength is 3 centimeters. Okay, so now we need to solve it. So what is the maximum unambiguous range? Okay, so that maximum unambiguous range, that is depending upon the PRF value. Okay, that's about a pulse repetition frequency. So we can find out a maximum unambiguous range, that is, we say that RQMB is equal to maximum is equal to what? A B0. Okay, that is about a C we can consider. So that I will write here a C is equal to what? 3 by 3 into 10 to the power 8, that is 2 into what? A PRF. So what will be the maximum unambiguous range? So we can consider that C is equal to what? 3 into 10 to the power 8, 2 into PRF, pulse repetition frequency is about 1 kilohertz, 1 into 10 to the power 3. Okay, after solving, we'll get that a unambiguous range is equal to what? A 150 kilometers. Okay, so this one we can find out that what will be the unambiguous. So generally we say that, okay, so what will be ambiguous range in terms of what? Okay, in terms of a given, uh, what we can say, that a range given there. Okay, so we need to know about that ambiguous range based on the pulse repetition frequency, and that pulse repetition frequency generally it is to be considered to get the range clearly. Means at a receiver, for operation of a receiver, we need to find out the, we need to consider the pulse repetition frequency for all the values. Pulse repetition frequency plays the important role for identifying the a target there or obtain the target there. So next one, we have seen that a tracing radar. So we talk about the next one. In a monopulse radar, in a monopulse radar, two antennas are two antennas are separated by lambda 2 and angle theta between the line of sight and the perpendicular and the perpendicular bisector of the line joining the two joining the two antennas is vertical. Okay, find the phase difference. Find the phase difference between the echo signal in the antenna. Okay, so we need to find out that what is the phase difference between the echo signal. Okay, the phase difference between the echo signal that will be given by. So we need to find out the phase difference is given by twice pi by lambda into d sine theta. Okay, so means we can consider that here in the case of a target, we are supposed to find out. So for this given antenna sending the signal, so that will be the angle theta. Okay, and that distance between this d, we can consider that about it spacing now. Okay, generally, or we can say that spacing between the two antenna d. So here the d or spacing between the antenna, because antenna is separated by the antennas are separated. Antennas are separated by lambda by 2. That's why d is equal to d. If you consider that d is equal to lambda by 2. So if you put here d is equal to lambda by 2, okay, so this one. So our equation becomes what? A twice pi by lambda into what? A lambda by 2. Okay, that is about a d into sine theta. And theta, so theta it is given is about a 5 degree. Okay, that is about the bisector of the line joining the two antennas. It is about a 5 degree. We can say that it is about a 5 degree now, sine of 5. So after solving, we'll get that a d psi. Okay, so we can consider that 2 get cancel, lambda get cancel, pi of sine 5 is equal to what? A 15.69 degree. That is about the phase difference between the echo signal. Okay, this is nothing but the phase difference in the ecosystem. Phase difference means what? So we have the two different loads we are getting. Okay, so through this particular antenna. So we have considered earlier in the case. Okay, likewise. So what will be the phase difference? Simply. Okay, so whatever the uh, beam or lobe pattern generated according to that, we can find out the phase difference here. Okay, this way we got the phase difference of the antenna. So next, in monopulse radar, in monopulse radar, two antennas are used to produce a phase difference of 20 degree. Okay, phase difference of 20 degree between the ecosignal, between the ecosignal. It operates at a frequency. It operates at a frequency of 1 gigahertz. Find the spacing, find the spacing between the antennas, spacing between the antennas if the angle is okay. That angle we can consider that theta is equal to 10 degree. So here we need to find out a del psi is equal to what? A twice pi by lambda d and sin theta. That theta is given, this phase is given, del psi is given. Okay, this one is given now. So our aim is about to find out that, so what will be the value of a d here. Okay, so we can consider that. Okay, what will be the value of a del psi? So we can find out that d is equal to what? Del psi into what? A lambda. Okay, this one we need to find out. Divided by a twice pi into sine of a theta. The theta is given is about a 10 degree here, and the phase difference. Okay, the phase difference is about it 20 degree. If you put here a 20, that is about lambda is equal to what we are getting for this operating frequency is about a 1 gigahertz, and theta is nothing but what? Sine of theta. Okay, so theta is equal to 10 degrees here. So if you put that, so we'll get that d is equal to 9.6 centimeter. So that's all about our tracking radar and a MTI radar. With this, we stop here. So thank you all of you.